Hello again. In the last video, I just finished up talking about differential leveling, and in this video I'm going to talk about trigonometric leveling. Trigonometric leveling. Alright, trig leveling. In the last video, I already stated on what the total station uses to solve for this vertical difference. Right, it's called the vertical difference. So trig leveling uses trigonometry to solve for vertical differences, right? Or distances, right? It could be called a vertical distance or a vertical distance. Right, I'm going to explain what this is right now, or what the heck I'm talking about right now. Okay, so leveling, I already said, was the process of transferring elevations from one point to another. And I said that there was two ways of doing this, and one way is through differential leveling, and one way is through trigonometric leveling. I mean, there's more ways of doing it. These are very common ways to do it. And I said that differential leveling is a little bit more precise than trigonometric leveling, and I will show you the reason why that is if I have enough time in this video. But right now I just want to kind of define it and show you how you can use it. Okay, so I'm going to draw a point here, right, in the ground. I'm going to draw the ground. Right, and then I'm going to draw another point way down here. Okay, so before I start doing visualization stuff, let me just define what the total station uses to solve for these vertical distances or vertical differences. So if you have, I'm going to come down here, I'll come back to that. Alright, so say you have a total station set up here. I said you're using a zenith angle, so your zenith is going to be straight up. Right, and say you're viewing a point somewhere out here. Right, this line is not level. Right, this line is not level. So there's going to be an angle, a zenith angle to this. Right, this is going to be your ZA or zenith angle. Alright, so what this does is you can form a right triangle. I don't know if you see it or not, but right here, right, this is 90. Alright, so what we use to get our point's right here. This is point 1. You use a slope distance and your zenith angle, right? This is going to be your slope distance. So how do you solve for this vertical change, right? Because we want to get to this point right here, where at the top here we want this vertical change, right? We want this distance right here to get to the elevation up here, right? So how do we solve for that? Well, it's the zenith angle and the slope distance, so we have to use trigonometry using what function? Right, so it's going to be, this vertical change is going to be adjacent over hypotenuse. So it's going to be the cosine, right? Cosine of theta is equal to opposite over hypotenuse. So it's going to be the cosine of the zenith angle is equal to, I'm sorry, this is adjacent, I'm sorry, adjacent, right? This side is adjacent. So adjacent over hypotenuse. So to solve for the adjacent side, we multiply both sides by h. So A is equal to h times the cosine of the zenith angle. H being the vertical difference or vertical distance. No, I'm sorry. A being the vertical difference. H is your slope distance. Slope distance. All right. So now that you know that, well, let me just define it fully. So your vertical difference is equal to your slope distance times the cosine of your zenith angle, right? Times the cosine of your zenith angle. This is the definition of the vertical difference, and this is what the total station, right? The total station calcs out your vertical difference for you. So most of the time you don't even need to do, you're not going to even doing this trig. It's going to be doing it behind the, inside the total station. It's going to process this number, whatever it is on the screen, right? It's going to show it on the screen. But I just wanted to show you how it actually does it. Okay, now that you know that, let's go back up here, and I'll show you the complete step, right? From this having an elevation over here. In the last video I said the elevation was 100. Let's do that again. Elevation is equal to 100. Right, and we want to get the elevation up here, over here. So in this case, we could set up on this. We could set right up on this. Right, we'll set up right over this point with our total station. And we are going to measure, if we have, now we're going to need a range pole or prism pole right over here. And we're going to shoot a slope distance to this prism. Right, we want to be right in the center of the prism, right? Vertically, we want to be right in the center of the prism. Horizontally, we want to be in the center of it too. Right, and we're gonna get the vertical difference. Right, if this is a horizontal line. And this is 90. We want this distance right here. Right? What's that distance? But we have the elevation down here. So we're going to have to add this distance. Right? The distance from the survey marker to the height of the instrument, right? This is going to be, usually shows a dot on the side of the total station where the optics, the center of the focal point of the instrument is, right? It'll show you the exact point of where everything is measured off of the total station. Right, so you want to get this height, say it's 5.12, right? That's a good height of instrument, 5.12. All right, and what we're going to do is we're going to push a button on the total station that shows you a vertical sign, right? That'll be kind of like, depending on what kind of total station you have, but it'll show a button like this, and it'll show a triangle, right? It'll show a right triangle, and you want to hit it enough times so it shows this thing, right? It'll show a bar next to the vertical one, right? You want to measure the vertical difference. So say in this case it's 0.24, right? Plus meaning this prism at the center of the prism is 0.24 higher than the total station, right? Than the focal point of the total station. So what do you want to do? Say, well, then you need to know the height of this, right? You need to know the height of this to the survey marker, right? Say this is 5 feet. So you're going to add to 100, you're going to add 5.12, 100 plus 5.12 is 105.12 plus 0.24, that's 105.36, right? That'll get us to right here. Then we want to minus 5, so it's going to be 100.36 feet. So the elevation at 2, so this is 0.1, this is 0.2. The elevation at 2 is 100.36. Okay, so that is the basics of trigonometric leveling. There's a thing called vertical eccentricity, where if you're reading a zenith angle on a point, you flip the scope 180, turn the total station towards the prism pole again, you're guaranteed your vertical angle is going to be different than the vertical angle you looked at it before with, right? That's called vertical eccentricity, which means that when you take the cosine of your zenith angle, the cosine of your zenith angle multiplied by your slope distance is going to be different, right? You're going to have two vertical distances that are different from each other, right? So this vertical difference is going to change, right? Whether you look at it directly or in reverse. So it might be indirect, it might be plus 0.24, in reverse it might be 0.26. Right, so usually what we do is we'll take the average, we'll view both sides and take the average, right? So this will be plus 0.25. And this eliminates error, right? But there is error in your machine, and you want to kind of get it out, because the cosine function, this is one reason why this vertical angle isn't as good, is because, I mean, trigonometric level isn't as good as differential leveling, because the cosine function has a real large slope at around 90 degrees. So so if you change the vertical angle just a hair, it's going to change this number quite a bit, right? It's going to change if you take the cosine of an angle, change the angle just a bit, take the cosine again, the number is going to change quite a bit. So that's why multiplying that by a number, it's going to change that number with, even if you move change the zenith angle just slightly. So you want to be careful. I'm going to explain this more in the next video, so see you soon. Hopefully I haven't confused you too much.